Hello and welcome to a screencast on the first lesson of biomechanics within anatomy and physiology. So we're going to do a short screencast today which basically looks at Newton's laws of motion. Now, key thing we're focusing on, we will be focusing on tomorrow's lesson, is kind of how objects or bodies move. First misconception I need to clear up before we get started is when I use the term body, I'm not talking about the human body, I'm talking about an object. So basically what we're going to have a look at is if a body or an object moves, how does it move? Now, Newton came up with three laws that kind of explained how a physical body or object can move. These three laws are outlined above. If you have a look here, I've got law 1, which is the law of inertia. And basically, what I need you to do is make sure that 100%, when you come into tomorrow's lesson, you've had a real good go at trying to remember and memorise Law 1, Law 2, and Law 3 down here. Now, the things that are kind of below, in bold, I'm putting the cursor over now, these are examples of using a penalty kick in football to try and give you some kind of practical application. So if I go through quickly then, law 1, this law, inertia, suggests that a body will remain at rest, stationary or uniform velocity until an external force is applied. So what that means is, if you imagine the golf ball, it would stay on a tee until a force was applied to it. Now that force would obviously be the golf club hitting the ball and it would move it off. So the first law is saying that any object or body will remain at its kind of stationary position, or if you're putting it in technical terms you have to learn, remain at rest or uniform velocity until an external force is applied. Now I've used the example here of a ball, e.g. on a penalty kick in football or a conversion in rugby, will remain on the spot until the foot, the external force, is applied to it and kicks it. Now, after you've kicked it, Newton's second law refers to the law of acceleration, and this law proposes that the rate of change of momentum is directly proportional to the size of the force and the direction of the force that is applied. So what we're saying there is, that ball that is on the spot will not move unless you kick it. That's the law of inertia. Acceleration is saying, the harder you kick the ball, the faster it will accelerate towards the goal, which would make sense, and the direction in which you apply the force will dictate which direction it's going. So for example, if you kick the ball straight through the middle, the ball is going to go in a straight line. So basically, as you can see there, we're looking at that law. If I put down here size, bigger the kick, or the stronger, or the harder, the more force that's applied to the kick of the penalty shot, the faster it will accelerate. And if it goes to the centre of if the force goes through the centre of mass, e.g. the middle of the ball, it will go straight. If you see sometimes people, certainly in a football penalty, the aim sometimes people will try to curl the ball into the top corner. That will be when you'd hit the ball outside the centre of mass. So if you imagine a round ball, the centre of mass is directly in the middle of it. People kick across that centre of mass, which causes a swerve. That swerve will hopefully, or what people use it, is to take the ball away from the goalkeeper, and that is something called angular motion, which we'll look at a little bit more later. Final law basically proposes, or the law is called action-reaction, and it proposes that every action has an equal and opposite reaction. For example, if the force that's applied by your foot on the ball will have an equal and opposite reaction from the ball onto the foot, and that causes the spinning movement when you kick a football. So if you think about it in other ways, it might be when if you're doing swimming and you're thinking of a tumble turn, when you push off, the force of your foot against the wall, there's an equal and opposite force pushed off the wall against your foot, which causes that change of direction. So don't overthink these, okay? What I do require from you for tomorrow is to say, right, these are the kind of things that some people get a little bit anxious about. However, there is no way in a million years you cannot have a look at this and say, right, there are three laws, according to Newton, that explain motion. Law 1, inertia. Law 2, acceleration. Law 3, action-reaction. Now, for tomorrow's lesson, your core now notes 100% should have at the very least the definition of the law. What I'm going to ask you to do tonight, after you've emailed me the homework that you're supposed to be emailing tonight, you should 100% be trying to learn these laws. Now, I will do a variety of activities tomorrow to try and make sure we embed these, but they're tricky definitions. But let's be honest, you can learn definitions from the age of 6, 7, 8 years of age, so there's no way that with a bit of effort you can't try and get these stuck in your head tonight, tomorrow morning before our lesson, and try and really make sure that you have a good idea of the name of the law and a good idea of the key terminology required to define it. Tomorrow's lesson will be about applying examples to it. If you want to put these examples in for a penalty kick in football, okay, you can do so. Obviously, I'm thinking of our group now. We have hockey players. You can apply this to a penalty corner when it's stopped. You can also apply it in rugby to a conversion, and then finally you can apply it, I'm trying to think of anything else. We'll have a look at things like tennis serve. So have a look at these things. If you want to add examples to it, you can, but certainly 100% you must have had a go at learning these laws, the names, and also the definitions. That is key. That's what will be required for the exam. Okay, thank you.